Okay, so today we're going to talk about spread. We're going to look at what it means, how you found it mathematically, how you define it mathematically, and then how you're going to write it up for your paper. Okay? Again, we're not writing a book here. 3 sentences for each one is enough. Right? And the beauty of spread and shift is that the 3 sentences, the ideas behind the 3 sentences are identical. Right? You're going to tell why there's a spread, or what there is about the spread. You're going to give the proof numerically, and then you're going to relate it back to the context. And the very last 3 words of this last sentence is going to be in this sample. You guys get that wrong, I'm going to be so sad. Okay? Here we go. So let's look at measures of spread. So we're going to identify the range and interquartile range of a given sample. We've talked about that word before. Does anybody remember what range means? If we're talking about the range of a set of data, it's simply the maximum minus the minimum, right? Good. And we're also talked about interquartile range. Remember, interquartile range is that middle 50%. So if you're doing the interquartile range, it's simply the upper quartile minus the what? Lower quartile. Okay? And we're going to talk about both of those. Then we're going to be comparing the spread of the data in some sample groups, and then we're going to discuss how to write that up into your report. Okay? All right. So here we have a graph, box plot with some information, and so we're talking about the measure of spread being the range. What I want to talk about here is there is a range for the full set of data, and there's also something called the interquartile range. Now, it's difficult for us most of the time to just be able to look at the graph itself and get those numbers. Now, sometimes this one's pretty straightforward. It's fine. But many times those numbers are decimals, and so it's more difficult. But do you have to read the data points from the graph in order to be able to do the math? No. They're always given to you in your statistical summary, in the red, right? And again, this graph was created with NZ Grapher, so it will look identical to the one you're using. Now, this one isn't a comparison of 2 data sets. It's just one data set, just to show you what range and interquartile range mean. Okay? Right, so we have a set of data with cans, weekly number of soda cans purchased. And first thing they want to do is find the range. Well, the highest data points occur at 14. The lowest data points occur at 1. So to get the range for the entire set of data, it's 14 minus 1 or 13. All right? So you can always find the range. The next one we're going to talk about is the so we're going to look at the range and be able to compare them. So here they have some 2 different sets of data points. So this is what yours is going to look like. Two box plots stacked together, and you're making a comparison with Ben and Beth's. And they're talking about the diameters of some ball bearings. And you see that they have exactly the same median, right? So is there a median shift on these? Nope. Okay. But if you look here, Ben's is shifted to the right. There's a quartile shift here, right? So you could describe that. But for right now, we're just talking about the range of these sets of data. So if I was wanting the range for Ben's, you would simply take the upper value minus what? The lowest value. So the maximum minus the minimum. And for Beth's, you'd do the same thing. But when you're looking at these, if you just look at this piece, you see that the range for one of them is going to be much bigger by just looking at the graph. Which one? Has the greatest range? It's Beth. Yeah, she's got hers has the greatest range, doesn't it? Okay? Good. All right. And what you can conclude from that is that if his has the smaller range, and we're talking about diameter of these ball bearings, then his are more accurate than hers overall, right? Some of hers are much smaller and some of hers are much bigger, even though the diameters are not, the values are not that huge. Okay. Now, Having talked about range, I'm going to tell you that it's almost worthless. And you'll see why in just a moment. However, the interquartile range is very valuable, right? That middle 50% of the data is what we're more interested in. And to find the interquartile range, we're simply going to take the upper quartile minus what? The lower quartile, okay? And that's what's called the interquartile range. So if you look here, the upper quartile is 10, the lower quartile is 3. Again, you don't have to look at the graph to get that. You can get that from your summary statistics. And that gives you an interquartile range of 7. So therefore, the interquartile range for this particular sample group is 7 soda cans. Right? So it's still found the same way. It just gives you much more valuable information than a range. And you're going to see why in the next slide. Look what happens to the range of a set of data if you have an outlier. Remember, an outlier just means one point of data that's way off from the others. As the outlier gets further away, the range gets bigger. Yeah? So that one point is having a huge effect on the range. But notice that as you move that one point back and forth, does it affect the interquartile range? Not at all. And it never will. Those points on either end will never affect the points in the middle. So therefore, the interquartile range makes for a much better comparison because it stays stable, right? The outliers don't affect it. So you do not have to mention range in your report. Instead, when we're talking about spread, you're going to use which thing? Interquartile range, right? Okay. Making my own questions here. It's never a good sign. Okay, so that's the one we're going to focus on as our measure of spread. So don't mention range. You can mention range if you want to, but there's really no point. If you'd like to compare the ranges, that's just one more feather in your cap, but it's also more for me to read. I didn't say that yet. Oh, well, it's on the recording. Don't play it to your parents. All right. The following shows weights of red snapper caught during the summer and winter. So if you look at just the range for summer and winter, they're pretty close, aren't they? The range here goes from there to there. The range here goes from there to there. So doesn't look to be much difference, right? But the reason for that is, look at this one point from the winter one. It is way over from all of the others. Here we have the last point here, and then all of this area with no data in it, and then that one data point. And so it throws the range off significantly. Okay? But if we look at the interquartile range from here to here and here to here, those values, that value, and there's another one, a little bit one in the summer ones, those values do not affect those boxes. So those are the ones we want to be able to use. Okay? So, and that's another reason why you'll see in that exemplar that they say the shift based on the interquartile range. It's just a much more stable value to use. So based off the sample, would we say that the weights of red snapper are more diverse during the summer or the winter? Well, if you're looking at the range, they're more diverse during the what? Winter. But if you were looking at the interquartile range, which one is more spread out? The summer, right? So depends on the value you're looking at. And which one is a more reliable value? The interquartile range, because it stays stable, whereas outliers like this one would have a great effect on the range. Okay? So just a little bit of why we would look at interquartile range instead of the range. All right? But again, spread is really easy to see. Box longer? Yes, more spread. Totally common sense, right? All right? Now, you will have to calculate the ranges, but when you're doing interquartile ranges, again, it's just the upper quartile minus the what? Lower quartile. So make sure you know the math between it. Then you can just compare which one's bigger, and that'll show you which one has the most spread, right? So you can do it visually, but you also have to support it with the numbers. Now, these are just ranges, not interquartile ranges that they did. But if you do the interquartile ranges, you'll see that it exactly flips. So summer becomes much bigger than the winter. All right? Okay. So you're going to have some where you're going to just be reading those ranges or finding those ranges. Make sure you're careful about, are they asking you to find the range or the interquartile range? Let's talk about how to write it up. When you're describing spread, you're going to see it's almost identical to the way we describe shift. You're going to make the observation, any difference in the interquartile ranges of the two sample groups. Okay? You're going to provide evidence, which means what are the numbers. And then finally, you're going to use context to state whether the difference it means, what it means in context of the investigation. Those are identical to the 3 points that we made when we were using shift. Right? So let's look at a couple of examples of how that works, and you can play with it. So here is a set of data. You have you're again comparing interquartile range here. Right away, if you just look at these, which one has the most spread, or the widest spread? Mountain bikes or road bikes? Mountain bikes, right? Okay, so that's easy. But you also have to give the actual numbers. So the data in the mountain sample group is more spread out than the data in the road sample group. That's just an observation. And you can get that straight from looking at the boxes, right? So that's always the first thing, just the observation. I see that this is happening. But look carefully at the wording. More spread out than the data in the road sample group. You must name the two populations, and you must tell whether it's more spread out, or if you reverse that, you could say the other one is less spread out. But usually we talk about the one that's more spread out. Okay? But if you reversed it, that's fine. If they were asking you a specific question, and they won't because this is your inference paper, right? But if you were trying to prove a point, and you said that, and you thought that the road samples would be bigger, then you might want to say the observation is that the road sample is actually smaller, right? So you can give it whatever emphasis you want. Okay. The IQR for mountain bikes is blah, right? So look at this thing. They're not only showing the number, but what else are they showing? The calculation, right? I need to see it. I need to see that you know I need to see where those numbers are coming from. Someone reading this report should be able to look at what you've done and see where your numbers came from. All right? So you need to show the math. And then this is whatever for the mountain bike, okay, which is that. Okay? So the two calculations of interquartile range for each data set, and that it's this much bigger. That is identical to what we did on the other one, right? Okay? So, except we're using different numbers because the math, and it makes the math is a little bit different. And finally, the last thing is related back into context. This means that back in the population, mountain bikers should tend to have more diverse inner tube pressures than road cyclists. Or you could also say that mountain bikers should tend to have more diverse inner tube pressures than road cyclists in this sample. Right? They mention the population, but you could also mention the sample. You're going to see both ways. But you can infer that from your sample, the same thing should be happening in the population. That's why they put it that way in this case. Okay? Let's just look at it. So here you go. Those same things. Observation about the difference in the IQRs. Evidence for the observation, support it with numbers. If you don't support it with numbers, then it's garbage. Okay? And finally, stating an observation about what it means. And you can either refer back to the population or you can put in this sample. Right? But of course, our whole point is using the sample to infer something about the population. Okay? And they give you this little important thing. IQR is more important than range, so do not use range, use IQR. Okay? How does it look? Yeah? Pretty good? All right. Let me stop the